Right, GCSE question of the week, week 19, and these are the higher tier only questions, so they're going to be tough. Okay, one is an iteration question. A, show that the equation x cubed plus 4x equals 1 has a solution between x equals 0 and x equals 1. Right, now there are a couple of ways to do this, but the safest way to make sure you get the marks is for a start. Just rearrange this slightly so that you've got the equation equal to 0. So in other words, we're going to subtract 1 from both sides so that that left hand side is equal to 0. Okay, and as soon as we've done that, we're then going to substitute in the given values for x. So for a start, we'll try x equals 0. We'll start with there x equals 0 because it's telling us that this equation's got a solution between x equals 0 and x equals 1. So we're going to plug in x equals 0. That's going to give me x cubed is 0 cubed, which is 0, plus 4x, which is 4 times 0, which is 0, and then minus 1, okay, which clearly gives me negative 1. Okay, that's not 0. Now let's try x equals 1. We'll substitute that in. Okay, so 1 cubed, that's going to give me 1, plus 4 times 1, that's plus 4, and then subtract 1. So we've got 5, subtract 1, that gives me 4. Well, clearly that's not 0 either. So when x is 0, we get an answer of minus 1, negative 1, instead of 0. When x is 1, we substituted x equals 1 in, we got an answer of 4, which is greater than 0. So x equals 0 substituted in gives us an answer of negative 1. X equals 1 substituted in gives us an answer of 4. Somewhere between minus and 1, 4, we must get the required answer of 0. Therefore, somewhere between our substituted values of 0 and 1 must be the actual solution. Okay, x must lie between 0 and 1. Now the absolute safest way to ensure you get the last mark is to state that there's a sign change between those two answers. So from negative 1 to positive 4, there's a sign change there. Okay, and that means that our solution of 0 must be between those two values, so that sign change proves that the solution for x must be between 0 and 1. Okay, so substitute in the two values they give you for x. Okay, you'll get one positive, one negative answer. Make sure you state there's a sign change between those two values. Okay, question B. Show that the equation x cubed plus 4x equals 1 can be rearranged to give x equals 1/4 minus x cubed over 4. Okay, well I notice we've got the x cubed there, and the x cubed there, and we've got an x there, we've got 4x here. So dividing by the 4, I assume, is where we've got these quarters for, these denominators of 4 here. So what shall we do? Well, this x part, it's got to come from this part. So I think I'm going to subtract the x cubed so that I get the 4x equals 1 subtract x cubed. That's starting to look good because my x bit is now on the left. Okay, how do I get x on its own? Well, I'm going to divide by 4. So if I divide by 4, we're going to get x equals, you can either just realise straight away that's exactly the same as what they're giving you, or we could have had an intermediate step where we put x equals 1 minus x cubed all over 4, and then separated those two fractions to 1/4 minus x cubed over 4. Okay, all done. Nice and easy. So this was A, and this was B. Starting with C, starting with x0 equals 0, use the iteration formula xn plus 1 equals 1/4 minus xn cubed. That's not very well written there. That should say xn cubed over 4 twice to find an estimate of the equation x cubed plus 4x equals 1. So we're going to start with this value. That means plug in that value into here and get a solution here, and then repeat. So let's do it. Okay, we've got xn plus 1. Well, if we start with x0, xn plus 1 is going to end up just being x1. So my x1 value is going to be 1/4 subtract our starting value, which is 0 cubed, divided by 4. So x1 is 1/4 subtract 0 cubed over 4 and make that nothing. So x1 is a quarter. So what are we going to do now? We're going to take our value for x1, which is a quarter, and we're going to substitute that back into here for my xz. That's going to give me x2 equals 1 quarter, subtract my new value 1 quarter cubed, so I've got to be careful, I've got 1 quarter cubed divided by 4, which is a bit messier. Okay, let's simplify that. We've got x2 equals 1 quarter, subtract, right, a quarter cubed. Okay, so I could cube the top, that's 1, I could cube the bottom, 4 times 4 times 4, that's 64. And we've got all of that over 4. Okay, got to know how to deal with these. So that's going to give me x2 equals a quarter, subtract, now a 64th, if I then divide that by 4 again, that's going to make that 1/64 4 times smaller. Okay, so this is the same as multiplying that denominator, the 64 denominator, by 4. It's going to make it 4 times smaller. It's going to give me 1 over, and then 64 times 4 on the bottom. Okay, double the 64 is 128. I think that's going to be 256. So x2 is equal to a quarter, subtract 1 over 256. What do we get? Okay, so we've got, if you like the fraction button way, we've got 1 quarter, subtract 1 over 256. Oh dear, falling to bits. We get x2 equals, what was it? 0.246. Okay, doesn't specify any number of decimal places. I'm going to leave it as that, 246, sorry. Okay, now, it's worth saying that you didn't need to leave all these as fractions. Okay, that 1 quarter cubed, you could have put that straight into your calculator as 0.25 cubed if you were happy doing it that way. Right, and it's also worth saying that our answer of 0.246, if we plug that back into our equation here, it should give us an approximate answer of 1. That was the whole point of doing it. And it's also worth saying you don't have to worry about where the iteration formula comes from or why it's going to give you an approximation. They're going to give you that, okay, to use. You don't have to derive it or worry about where it comes from. So let's try 0.246 cubed. And then we're going to add 0.246 multiplied by 4. Ugh. So we're doing x cubed plus 4x, putting our answer back in. When we press equals, we should get an approximate answer of 1. Brilliant, 0.99888. So it looks like we got the right answer. 0.246, when we substitute it back into x cubed plus 4x equals 1, gives us our expected approximately 1. So the iteration formula worked. Okay, number 2. Prove algebraically that the straight line with the equation y equals 3x minus 10 is a tangent to the circle with the equation x squared plus y squared equals 10. So that word's going to be important. I need to know what that is. And circle equation is going to be important. So I find it very hard to get my head around these without drawing a sketch. So what do we know straight away? Well, we know that we've got a circle with the equation x squared plus y squared equals 10. And hopefully you know that that means that the radius of this circle is root 10. So that's root 10. That's root 10. And I don't think we need it, but that's negative root 10. And that's negative root 10. Okay, the line y equals 3x minus 10. Well, that looks like it's already in y equals mx plus c format. So we know a fair bit about that line already. We know the gradient m is equal to 3. So this line's got a gradient of 3, and we know its intercept is negative 10. Okay, so it cuts the y-axis at negative 10, it's got a gradient of 10. Okay, right, now if it's a tangent to this circle, it's going to do that, or that, or that, or that. It's going to touch the edge of that circle just at one single point. Now, we may already have enough information to work out roughly where, but to work out exactly where, at the point that those two lines touch, we know that y equals 3x minus 10, and x squared plus y squared equals 10 must be solvable as a pair of simultaneous equations, because at the point where they meet, x and y are the same. So we're going to solve these simultaneous equations to find out the coordinate where those two lines meet. Alright, now I think we're going to need a substitution method. I think we'd better turn this equation into y squared by squaring both sides. That's going to give me y squared equals 3x minus 10 multiplied by 3x minus 10. And if we expand that, we get y squared equals 9x squared. If you're foiling, you're then going to get minus 30x minus 30x plus 100. So we know y squared is equal to 9x squared minus 60x plus 100. And we can then substitute that y squared in for the y squared here, because this is y squared. So we can say, let's go over here, that x squared plus 9x squared minus 60x plus 100 equals 10. So I've taken this and inserted it here. So we've got x squared plus this is equal to 10. Alright, simplify that. It gives me 10x squared minus 60x plus 100 equals 10. Alright, so to solve this, that's going to give me 10x squared minus 60x plus 90 equals 0. Okay, now to make things a bit simpler, we can then divide through by 10. That's going to give me x squared minus 6x plus 9 equals 0. So we're allowed to do that. We can divide every term by 10. 10x squared divided by 10 is x squared, minus 60x divided by 10 is minus 6x, plus 90 divided by 10 is plus 9, and 0 divided by 10 is still 0. So that's allowed. Now we can factorise. Okay, we want x. Now I'm looking at thinking straight away, it's x minus 3, x minus 3, minus 3 times minus 3 is going to give me the positive 9, minus 3x, minus 3x, minus 6x. This looks good. So my solution is x equals 3. And if we substitute that back into either of the equations, let's try this one. We can find y. So y is going to be, we now know x is 3 times 3, and then subtract 10. So that's 9 subtract 10, y is negative 1. So finally, all that work to know our coordinates of the intercept. The coordinates of the intercept are the point 3, negative 1. So 3, negative 1 is where the two lines intercept. Well, root 10 is a bit more than 3, so 3 is here, and negative 1 is maybe around there. So that point is the intercept. So we know our tangent does that. So we know that they touch at that point. Now what would it take to prove that that line is a tangent to the circle? Well, we know that a tangent touches the edge of the circle at a point where the radius hits it at 90 degrees. So if we could prove that this radius line here is perpendicular to the tangent, then we're good to go. And how shall we do that? Oh, we're running out of time. Oh, it's so exciting. God, you'll have to watch video C. Video C to find out. See you in a minute.